The following question reads, accompany 6 vehicles, a hatchback, a limousine, a pickup, a roadster, a sedan, and a van, are serviced during a certain week, Monday through Saturday. 1 vehicle per day. The following conditions must apply. All right, so we have our inventory. We have H, L, P, R, S, and V. And we're placing them in order Monday through Saturday. So we have Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Now, let's go to the rules. Rule number 1 tells us that at least one of the vehicles is serviced later in the week than the hatchback. All right, so that means that H is not going to be on Saturday. Okay, so that's easy enough. H not on Saturday. Let's go ahead to rule number 2. The Roadster is serviced later in the week than the van and earlier in the week than the hatchback. All right, so that tells us that we have V and then R and then H. Still seems pretty easy enough. That means that H can't be on Monday and H can't be on Tuesday because H has 2 vehicles to the left of it. And likewise, V can't be on Saturday and V can't be on Friday because V has 2 vehicles to the right of it. Likewise, R can't be on Monday and R can't be on Saturday, again because R has 1 vehicle to the left of it and 1 vehicle to the right of it. So now, before we move on to rule number 3, I want you to notice that we can combine rules 1 and 2 like so. So we have V and then R and then H from rule number 2. And from rule number 1, we know that H has to have at least 1 vehicle to the right of it, telling us that now V has at least 1, 2, 3 vehicles to the right of it, meaning V also can't be on Thursday. Likewise, now R has at least 1, 2 vehicles to the right of it, meaning R can't be on Friday. All right, now we can move on to rule number 3. Either the pickup and the van are serviced on consecutive days, or the pickup and the sedan are serviced on consecutive days, but not both. Okay, so here we have an either or, but not both. Remember, when we have our either or, it's going to be either A or B diagrammed. If not A, then B. So we're going to diagram this either or first. If P and V are not consecutive, so we have this PV block, since we don't know which one is first, we're going to have a little arrow depicting that their placement is variable. So if P and V are not consecutive, then P and S are consecutive. Contrapositive, if P and S are not consecutive, then P and V are consecutive. So this is the either or part of our rule. Now we still have not both. Now remember, if you have A, B, not both, we're going to draw that out if A, then not B. So we're going to write out if P and V are consecutive, then P and S are not consecutive. Contrapositive, if P and S are consecutive, then P and V are not consecutive. So this is our not both. So ultimately, what rule number 3 is trying to tell us is that P is not going to be sandwiched between S and V. So we're not going to have an S-PV block with S and V being variable. We cannot have this. And this is the main thing that rule number 3 is telling us. We're either going to have P and S next to each other or P and V next to each other, but we're not going to have a block of SPV together or VPS together. All right, now rule number 4. The sedan is serviced earlier in the week than the pickup or earlier in the week than the limousine, but not both. Okay, so again, we have an either or, not both, so we're going to draw them out. If the sedan is not earlier than the pickup, then the sedan is earlier than the limousine. Contrapositive, if the sedan is not earlier than the limousine, then the sedan is earlier than the pickup. Okay, so this is our either or. Now for the not both. If the sedan is earlier than the pickup, then the sedan is not earlier than the limousine. Contrapositive, if the sedan is earlier than the limousine, then the sedan is not earlier than the pickup. So this is our not both. And so ultimately, what this rule is telling us is that S will be sandwiched between P and L, because we can't have a situation where both P and L are to the left of S or both P and L are to the right of S. So that means we're going to have an LP and then S and then PL. And ultimately, what this tells us is that S has at least one vehicle to the left of it and at least one vehicle to the right of it, meaning that S can't be on Monday and S can't be on Saturday. And so the last deduction we can make is by seeing which vehicles cannot be on Monday and Saturday. So on Monday, we can't have H, R, and S, meaning the only three left that could be on Monday are L, P, and V. The vehicles we cannot have are H, V, R, and S, meaning we have a binary of a possibility of L or P. And so those are all the deductions we can make. We have our setup, our rules, and our deductions. Now let's go ahead and hit the questions.